Alright, let's first look at what is an improper fraction. An improper fraction is one that's top-heavy. The number on top is bigger than the number on bottom. So here we have an improper fraction. Now, saying it as an improper fraction, automatically everything we talked about probably goes out the window, but we also looked at this as a division problem. So if you remember division with remainder, 25 divided by 4, we could rewrite 25 as 4 goes into 25 6 times, so this was 6 times 4 plus my remainder of 1. Now we were dividing by 4, so if I actually go through and divide everything by 4, then I get that 25 over 4 is equal to, I have addition up top, so I can break these apart. Something was added, now I can unadd them. So 6 times 4 over 4 plus 1 over 4. The numerator and denominator are essentially in factored form. They have a shared factor, so I can cancel it out. So I get that 25 divided by 4 is equal to 6 plus 1/4. Now 6 plus 1/4, when we write this, when I have a whole number plus a fraction, we generally omit the addition. So we have 25 divided by 4 is equal to 6 and 1/4. So using division with remainder, we converted the improper fraction to what we call a mixed fraction. And a mixed fraction is one that has a whole number and a fraction. And so again, a mixed fraction is just the addition of a whole number and a fraction. So let's talk about mixed fractions or mixed numbers. Mixed numbers is a better word. Let's call it a mixed number. Let's talk about mixed numbers real quick. Now, I don't know about y'all, but me growing up, I was always told by my teachers that when I was adding mixed numbers, let's get a little problem here. Let's say I have 3 and 2/5 plus, 4 and 1/3. So I was told when I was adding these that I had to convert them into improper fractions, and we can follow those steps reverse in just a second. But I was told that I need to rewrite these as mixed numbers, rewrite these as improper fractions, find a common denominator, and add them together. But we know stuff, and we know that that is not necessarily true, because the mixed numbers are just the addition of the whole number and the fraction. It can be rewritten like this. And since we know the associative and commutative properties of addition, I know that I can do 3 plus 4 plus 2/5 plus 1/3. So I can rearrange the order and I can change the grouping. I can add my whole numbers and get 7. And now I can add my fractions and I get 11 over 15. Right, common denominator would be 15. So I get times 3 gives me 6, times 5 gives me 5, so I get 11 over 15, and this is 7 and 11/15. Now, of course, there are instances where you could end up, yes, with your whole number, but with your fraction being improper, so you would just have to carry over the whole. Let's see if I can come up with one real quick. So let's say we have 7 and 8/9 plus 5 and 3/4. So again, by using our associative and commutative properties or laws of addition, I know I can add my two whole numbers. 7 plus 5 gives me 12, and find a common denominator to add together my two fractions. So I'm adding 8/9 plus 3/4. The least common denominator here is going to be 36. So I need to multiply by 4. And I need to multiply by 9. So I get 12 plus 59 over 36. Now 36 over 36 would get me a whole, right? So let's separate this. This is 12 plus 36 over 36, which would be 1, plus, what do I have left over? 23 over 36. So now I have 12 plus 1 plus 23 over 36. And now again, I can add my whole numbers, and I get 13 plus 23 over 36, which we know is just a mixed number and can be written as 13 and 23/36. There we go. Now, how do I convert a mixed number back into an improper fraction? So let's say we have, 7 and 2/3. Now, to convert this back into an improper fraction or into an improper fraction, there are two different ways to do it. The first one, recognizing that again this is a mixed number, and I can rewrite this as 7 plus 2/3. Well, now I'm just adding fractions, right? This is 7 over 1 plus 2 over 3. I need a common denominator. That common denominator, since this denominator is 1, then I need to multiply it by 3 to get the common denominator, right? And that will always be the case because you'll always put your whole number over 1. So you'll always have a common denominator of the fraction that you have. So my common denominator is 3, which means I need to multiply 7 over 1 times 3 over 3. So I get 21 over 3 plus 2 over 3. And now I'm just adding regular fractions with a common denominator. So this gives me 23 over 3, right? So that's the legit way to write a mixed number as an improper fraction, right? Break it apart. We know this is addition, find a common denominator, and add them. Now, if we go back here, I'm sure all of y'all are screaming at me, there's a trick, multiply, add, and put it over the denominator, or however you say it. Yes, tricks are nice, it makes it easier shortcut and things like that, but understanding the why is very important so we can explain. So again, why is it that, let's come back here. So the trick, everyone is yelling at me. So the trick that we can do to convert a mixed number into an improper fraction is to multiply the whole number times the denominator and add the numerator. So 7 times 3 is 21. 21 plus 2 is 23, and I get 23 over 3. So much quicker, so much easier. So let's break that down. What did we do? 7 times 3, why? Well, if we back up here, we know we're always going to put the whole number over 1, which means my common denominator will always be the denominator of the original fraction, which means that I'll have to multiply my whole number by 3, hence the multiplying the whole number by the common denominator. Once I multiply, I'm supposed to add. So 7 times 3, we see that in step 3, and then add in 2. So where does that come from? Well, if you come back up and look at the legit way, once we multiplied my whole number to get the common denominator and got the equivalent fraction 21 over 3, we added, right? So we added that 21 plus 2, because they have the common denominator, and got 23. So that's why we would, or could, as a shortcut, multiply the whole number times the denominator, add the numerator, all back over my common denominator. Now, that being said, coming back over here, I told you, my teachers always told me, and maybe you, that when we were adding mixed numbers, I had to write it as an improper fraction. We see here that that is absolutely not true. Could I write them as an improper fraction? Sure. If you wanted to take that route, you absolutely could. But if I asked you to do it using the commutative and associative properties, you would be expected to do it this way. If I asked you to do it by writing them as improper fractions, then you'll do it the way that I'm about to show you. All right, so let's start by, I still want to add these two numbers, these two mixed numbers, 3 2/5 plus 4 1/3. But this time we're going to do it by writing them as improper fractions. So as we just saw, I'm going to use the shortcut. So 3 2/5 as an improper fraction. 3 times 5 is 15, plus 2 is 17, so I get 17 over 5, plus 4 times 3 is 12, plus 1 is 13, so 13 over 3. And my common denominator I see is going to be 15, so I need to multiply 17 times 3. So I get 51 over 15, right? Yep. And 13 over 3 times 5 over 5, so 13 times 5 is 65 over 15. So I end up with 116 over 15. And so 1 whole would be 15. Let me see. 30 would be 2, 45 would be 3. So 90 would be 6. So 105 would be 7. So 105 over 15 plus, what is that going to leave me? 11 over 15. Like I said, 105 is the 7th multiple of 15. So I know 105 divided by 15 is 7 plus 11 over 15, which we know is the mixed number 7 and 11/15. So just like we got there, so we could use associative commutative properties, or you can go with improper fractions. Understanding now the properties and seeing that I could keep my fractions so much smaller, I prefer this way. That's me. I prefer this way. I see I didn't write any equal signs. There we go.